Hello guys, welcome to another video from Computational channel. In this video, we're gonna solve the question number 13 from Sipser textbook, and actually this question is about basically to turn a NFA to a equivalent DFA. And yes, we have an algorithm that we can convert the NFA to a DFA, and we're gonna practice this algorithm in this question. And yes, this is the basic idea of this new question, and let's solve it together. Okay guys, as you can see here, this is the question number 13. Let f be the language of all strings over 0 and 1 that do not contain a pair of ones that are separated by an odd number of symbols. Give the set diagram of a DFA with the 5 set that recognize f. You may find it helpful first to find a 4-state NFA for the complement of f. So first, actually, I write the question here in my whiteboard. So yes, this is the question. And first, let's use from this hint that we have. You may find it helpful first to find the 4-state NFA for the complement of NFA. And actually, if we want to define the language for complement of this language that we have here, first, let's call our language actually. Here, our language is f. So we want to construct an NFA for complement of f that we will actually write it like this. Complement of f is something like, something like this here. This is the complement of f. And the complement of f actually is a language that better I say, it is a language over 0 and 1 that contain a pair of ones that are separated by an odd number of symbols. So we can separate ones by an odd number of symbols that we have here. So first, we know that we can start from, and here we want to construct an NFA. So first, we have our starter state here, and this is an NFA, so we can actually use from arrow something like this here. Yes, this is better. We call this actually set here Q0, and in this state we have a transition for 0 and 1 over our string, because we don't know when we can start our pair of ones. So we have an arrow for 0 and 1 here like this, and after that we have an arrow for only 1 to go to our next state. Actually, this is the beginning of our pair of ones that we can separate them by actually an odd number of symbols. So here, this is the start of our pair of ones. We call this here Q1. Yes. And after this state, we can separate our pairs by an odd number of symbols. So if we see odd number of symbols actually, we will reach our next new state, call this Q2. And after that, if we see another symbols, it means that we have even number of symbols that we can separate our pair of ones, and we will back to our previous state, something like this. Yes, and finally, if we have other ones that we start our pair, and with this new one, we're gonna end our pair. So it will become something like this here. We have a new one, and yes, actually this is the pair of our ones that we separated them by an odd number of symbols. So yes, this is something like this, and finally I say that we call this Q3 is our accept state here, and after this the string doesn't matter for us. So we have an arrow like this, and this is the basic, actually let me draw this here better. Yes, this is better. This is the basic NFA for our language that we have here. And now we want to construct a DFA based on this new NFA that we have here. So all we have to do first, we have to initialize, or better I say recognize, our starter state in our NFA. And we know that here Q0 is our starter state that we have here. So For construct a new DFA, first we have to construct a actually table here, something like this. We will draw a table here. First column is our states, and next two columns are for our transitions, actually for 0 and 1s. So here is for transition, and first column is for state, is something like this, and our starter state is Q0. So yes, this is okay. Actually better, yes, something like this. And let us start from our NFA. We are in Q0, okay? If we see a 0, we know that based on this transition that we have here, we will loop over our Q0 state. So with a 0 actually transition, we will go to Q0 here. So it will become something like this. And if we see a 1, we have two options. Based on this transition, we will loop over our Q0 state, and based on this transition, we will go to our next state, that is Q1. So it will become something like this here, Q0 and Q1. Yes, this is so good. And after that, we will pick one of our final result of our transition, like from 0 or 1. That for 0 we have Q0 that we already draw the result for this state, so we will pick Q0 Q1, and it will become something like this here, Q0 Q1. Here we have to actually start to go over our new state from these two states that we have here. So actually, for example, we have Q0 and Q1 here. If we see a 0 here, we know that based on this transition for our Q0, we will loop over our state in Q0 and we will go to Q0 again. So this is for Q0, and we have another transition for 0 here over Q1, and if we see a 0 here, we will go to our next state, that is Q2. So actually here, if I want to write the result here, it will be something like this. We have Q0 and Q2, yes, like this. And after that, now let's go for a transition for 1. For Q0, if we see a 1, we will loop over Q0, and from this transition here, we will go to our next state, Q1. And for Q1, if we see a new 1, based on this transition, we will go to our next state, that is Q2. So it will become something like this, Q0, Q1, and Q2. Yes, like this. And after that, we will pick one of our results. Here, I will pick Q0, Q2. So it will become like this, Q0, Q2. Here, and let's start again. We are in Q0. If we see actually 0 here, we will go to we'll loop over Q0 again. So here we have Q0, and for Q2, if we see another 0, we will back to our Q1 based on this transition here. So we have something like this. Actually here, we will back to Q1, and after that, based on transition over 1, we are in Q0. If we see a 1, we will loop over Q0, and we will go to our next state, Q1 here. So first we have Q0, Q1, and after that, we are on Q2. If we see a 1, we have two options. We can back to our Q1 based on this, and we can go to our next state, that is Q3, based on this transition. So actually already we add Q1 to our set, so all we have to do is that we have to add Q3 to our set here, so it will become something like this. Yes, so good. And after that, if we want to pick a set, we have to pick this set here. So because in our previous last step, we picked this set here, and now we have to pick the other set. So it is Q0, Q1, and Q2. So it will become Q0, Q1, and Q2 like this. So first, for 0 in Q0, if we see 0, we will loop over Q0. So here we have Q0. And for Q1, if we see a 0, we will go to our next state, that is Q2. And for Q2, if we see a 0, we will back to our previous state, that is Q1. So yes, it will become something like this. And for 1, we are in Q0. If we see a 1, we will loop over Q0, or we can go to our next state, that is Q1. So we have Q0 and Q1 here. And after that, for Q1 here, if we see a 1, we can go to our next state, that is Q2. And finally, for Q2 here, if we are in Q2, so if we see another 1, we have two options. We can back to our previous state, that is Q1, or we can go to our next state, that is Q3. So actually, it will become like this, Q3. Yes, this is so good. And after that, we have to pick another set, and I will pick this set here. Yes, I will pick this set, Q0, Q1, and Q3. So actually, I have to expand this table like this. We have Q0, Q1, and Q3. Yes. Here, if we see 0 in Q0, we can loop over Q0. So here we have Q0. And for Q1, if we see a 0, we can go to our next state, that is Q2. So yes, it will become like this. And finally, for Q3, if we see another 0, we can loop over Q3. So it will become like this. Yes. Actually, yes, that is correct. And after that, for transition for 1, in Q0, if we see 1, we have two options. We can stay in Q0 or go to our next state, that is Q1. So Q0 and Q1. And for Q1, if we see another 1, we can go to our next state, that is Q2. Yes. And finally, for Q3, if we see another 1 when we are in Q3, we can loop over Q3 and add Q3 to this set here. So it will become like this. Yes. And after this, we have to pick another set. Here, actually, we can pick... actually, the best option here is this set here, this huge set here. We have Q0, Q1, Q2, and Q3. We have all of our states. So Q0, Q1, Q2, and Q3. Yes. For 0, actually, we are in Q0. After that, if we see another 0, we will stay in Q0. So it will become like this. For Q1, when we see a 0, we can go to our next state, that is Q2. And in Q2, if we see another 0, we can back to our previous state, that is Q1. Yes, like this. And actually, when we are in Q3, if we see another 0, we can loop over Q3. So yes, again, we have all of our states here. And after that, for 1, we are in Q0, and if we see another 1, we have two options. We can stay there or go to our next state, that is Q1. So we add Q0 and Q1 here. We are in Q1, and if we see another 1, we have to go to our next state, that is Q2. And after that, we are in Q2, and if we see another 1, we come back to our last state, that is Q1. So, and actually already we add this state to our set. And finally, in Q3, if we see a 1, we can loop over our state. So all we have to do is that we have to add Q3 to this set. So it will become like this. Yes, and actually we tried this set here, and actually we have another set that we can choose, and it is this set here, Q0, Q2, and Q3. So again, we have to expand our table. If we add this set here, Q0, Q2, and Q3, yes, like this. Actually, we are in Q0. If we see another one based on this NFA, we can loop over our Q0 here. So we have to add Q0 here, and we are in Q2 based on this NFA. When we see a 0, we come back to our last state, that is Q1. So we have to add Q1. Yes, and we are in Q3, and when we see a 0, we can loop over our state, that is Q3. So all we have to do is that we have to add Q3 to this set, and it will end here. And finally, for 1 arrows, we are in Q0. We have 2 options. When we see a 1, we can loop here, or we can go to our next state, that is Q1. So we open new set, and we have to add Q0 and Q1 to this set here. Yes, this is so good. And now we are in Q2. In Q2, when we see a 1, we come back to our last state, that is Q1. So, and actually already we add this state here. So yes, and finally, when we are in Q3 and we see a 1, we can loop over our state here. So all we have to do is that we have to add Q3 to this set, and yes, this is the table for actually transfer our NFA to an equivalent DFA. And based on this actually table that we have here, we want to try to make a DFA. And actually, yes, I will draw it here. I hope I can draw it so well. So here, our start state, actually let me raise this, yes. Our start state here is Q0. So our start state in our equivalent DFA must be Q0, okay? So yes, we have Q0 here. And in Q0, we have, when we see a 0, we have to loop over our state. So I will add this arrow here, and we know that in a DFA, we must have the number of arrow that is equal to number of our alphabet. So for every alphabet, we have an arrow that give the successor of our node to us. So after this, if we see a 1, we have to go to a new state that's contain actually Q0 and Q1. So if we see a 1 actually here, we have to go to our next new state that's contain Q0 and Q1. Q0 and Q1. Yes, this is correct. And in Q0 and Q1, when we see a 0, we have to go to a new state that's contain Q0 and Q2 actually. So it will become like this, Q0 and Q2. And when we see a 1, we have to go to a new state that's contain Q0, Q1, and Q2. So it will become like this here, that's contain Q0, Q1, and Q2. Yes, like this. And after that, we are in this part, actually. We are in a state of Q0 and Q2. When we see a 0, we have to back to our last state, that is Q0 and Q1. So it will become like this. Yes. And if we see a new one, we have to go to a new state that's contain Q0, Q1, and Q3. So it will become like this. And here we have Q0 and Q1 and Q3 actually. Yes. Let me draw it again. Q0 and Q1 and Q3. Yes, this is good. And after that, we are in Q0 and Q1 and Q2. Actually, we are in this state here. And if we see a 0, we have to actually loop over our state, so it will become like this. Yes, and when we see a 1, we have to go to a new state that's contain actually Q0, Q1, Q2, and Q3. So it will become like this. Q0, Q1, and Q2, and Q3. So it will become like this. Yes, this is so good. And actually, after that, we are in new state that's contained Q0, Q1, and Q3. We are in this state. When we see actually 0, we have to go to a new state that's contained Q0, Q2, and Q3. So actually, it will become like this. When we see a 0, we have to go to this new state, Q0, Q2, and Q3. So it will become like this. And when we see actually 1, we have to go to our actually big state, hugest. And actually when we see a 1, we have to go to our huge state here. Actually, we have to back to our huge state. So we have this arrow here. Yes. And after that, we are in Q0, Q1, Q2, and Q3. If we see a 0, we have to loop over there. And if we see a 1, actually also we have to loop over there. So this is so simple. All we have to do is that we have to add an arrow for both 0 and 1 like this. And finally, we are in Q0, Q2, and Q3. And for both of these transition, we have to go to Q0, Q1, and Q3. So it will become like this for 0 and 1. And actually, yes, this is the equivalent DFA for our NFA. And actually, we have one more step here. We have to define our active state. So based on our NFA here, actually we are in our actually active state when we are in Q3. Okay, when we are in Q3, we are in our active state. So all of our sets that contain Q3 are our active state in our equivalent DFA. So our accept states actually are, if I want to show you, this is our active state here, and we have another active state that is here. We have Q0, Q1, and Q3. And we have another active state that's contain Q0, Q2, and Q3. That is something like this. And yes, this is all of the set that contains Q3, and this is the equivalent DFA for our NFA. But we have actually one more step to go. And based on the question that we have here, actually we have to give the state diagram of a DFA with 5 states. And actually the DFA that we have here, it's contain actually 1, 2, 3, 4, 5, 6, and 7 states, and we have to somehow actually transform it to a new DFA that's actually contain 5 states. So here actually we have 2 more steps. First, we made a complement actually operation on our language. So here we have to actually swap our active state and normal state. So in this actually NFA that we have here, if we swap the active state and normal state, our active states become, we have to remove this red line. Actually, oops, I will actually fix it. Yes. And this is actually Q0 here. And our active state will become first this state here. And this state actually it's become all of the sets that doesn't contain Q3. So we have this state and this state here. So based on this actually diagram, we have 4 active states that we have to keep all of them in our final DFA. But for other 3 states, we have this option. We can actually transform all of this state to a new state that we can call it dead or reject or something like this, that show us that we can't go to our active state based on this state over here. So actually the final DFA can become something like this. Actually, yes, we must actually keep Q0 here. Actually, yes, and we have this transition here over Q0 for 0. And if we see a 1, we have to go to our next new state that's contain Q0 and Q1 like this. And based on our DFA, when we see a 0, we have to go to our next new state like this. Here we have actually Q0 and Q2. And for 1 transition that we have here, when we see a 1, we have to go to our next new state like this. That's contain Q0, Q1, and Q2. Q0, Q1, and Q2. And here, actually, when we see a 0, we have to loop over our state, so it will become like this. And when we see a new 1, we have to go to another state that we call it dead or rejected state, so it will become like this. I forget this part too. We have this new state here that we call it dead like this. And when we are in Q0 and Q2, when we see a 0, we have to back to our last state, that is Q1 and Q0. And when we see a 1, we have to go to our new dead state, so it will become like this actually. And when we are in our dead state, there is no way that we can achieve our active state. So for all of other symbol here, we have to loop over this dead state. And actually, yes, this is the actually, oh, I forget to show you the accept state. All of the states that are not dead here are our accept state. So this is our accept state, this is our accept state, and accept and accept. And yes, this is the final DFA for the answer of this question. And I know actually this question contains a long solution. First, we draw an NFA for complement of our language, and after that we draw a table because we want to actually transform our NFA to an equivalent DFA. So first we draw a table for all of our state and transition, and based on this table we draw a new DFA here. And actually we complement our DFA. We know that for complementation, all we have to do is that we have to swap our active state to our normal state. And yes, here, and finally, somehow we optimize our DFA to we actually reach a new DFA that's only contain 5 states. So this is the solution for the question number 13 from Sipser textbook. I hope you guys enjoyed this video and learn a lot of things for your exam. I don't know, maybe you look at this question and actually issue like a hobby. I hope you enjoy it and learn a lot of things from my video. If you like it, like my video and leave some comment in comment part. Actually, I will read all of your comments, and this is a big motive for me. And finally, if you like my video so much, you can subscribe to my channel. And actually, this is the biggest motive for me, even bigger than the comment part. And yes, that's it. That's all we have in this video, and that's it. Have a nice day, guys. Goodbye.